Hello guys, this is Prashant from MyLearnCube. So in this lecture, we will continue our series on binary codes, and for this lecture we will learn a very important concept or very important code called gray code. It is very important from the perspective of gate. Many a times a question have been asked on this topic. So let's see. So before going to gray code, we have to see what do we mean by reflective codes. There is a term called reflective code. See, if I have a single bit, for single bit I have option 0 1. Okay, now if I have if I put some mirror in front of these codes, then they will get reflected. So when they will get reflected, put 0 0 and then 1 1. So these are 2-bit gray code, all possible 2 bits gray code, 2 bits gray code, and such codes are called reflective code. Such codes, that's why I'm referring this term called reflective code. This is 0, this is 1, this is 2, this is 3. This is gray code. These are gray code. Suppose if you want to generate 3-bit gray code, then you will what you will do? 0 0. You will put all these 4 before the mirror. 1 1 1 0, and then the mirror will get reflected them. 1 0 1 1 0 1 0 0. Now put 0 0 0 0 here and 1 1 1 1 here. So you will get, these are the gray codes for 0 1 2 3 4 5 6 7 and so on. So that's how you generate that's why gray codes are also called reflective code. Why? Because using n bit gray code, you can use the concept of reflection and can generate n plus 1 bits gray code. That's why gray codes are sometimes also called reflective code. Now before going to this, now how to generate means conversion. We will see now code conversion. And from code conversion, basically there are two types of code conversion: binary to gray or gray to binary. So we will see one by one. Suppose this is binary. The code is in binary 1 0 1 1, and I want to convert this into gray code. So how I will generate? Put first digit as it is, take XOR between first and second bit, it will give you 1. Then take XOR between these two bits, it will give you 1. Now take XOR between these two bits, it will give you 0. So this is the concept, this is the way how you convert binary to gray. And if someone keenly asks, if this is your B0 or not B0, if this is your okay, let's take this B0. If this is your B0, this is your B1, B2, B3, then you can put directly G0 is equal to B0, G1 is equal to, as I think you are now able to compute this, B0 XOR B1, G2 is equal to B0 XOR B1 XOR B2. Oh, sorry. G2 is the XOR of B1 and B2, and G3 is the XOR of B2 and B3. This is the way you generate gray codes using binary codes. This is the way. Take one example now. We'll see one more example. Suppose we have 1 1 0 1 0 0 1 0 1. Suppose this one. So I want to, this is binary, and now I want to convert this binary into gray. Very simple. Take first as it is. XOR between these two will give 0. XOR between these two will give 1. XOR between these two will give 1. Here 1. Here 0. Here 1. Here 0. And here 1. So this is the way to convert binary into gray. Now second conversion is your gray to binary. Second conversion is gray to binary. How you will proceed for this one? So in the previous question, previous concept, we have used 1011, and that has been converted into 1110. We will use that one only, 1110. So the way is, put first one as it is, Now take XOR of this and this and put this here. The result is here. 1 XOR 1 is 0. Now take XOR of result this one and the next one. You will get the result is 1. Now take XOR of this one and this one, you will get 1. So 1011 is the binary corresponding to this, and you can check from here. 1011 was the binary. So I will summarize this concept. Suppose you have binary 1011 and you want to convert it into gray. Suppose. So what you will do? 1 XOR of this, XOR of these two bits will give you 1, XOR of these two bits will give you 1, and XOR of these two bits will give you 0. And if you want to convert this gray into binary, what will you do? Put this one, take XOR of this and this, it will give you 0. Take XOR of this and this, it will give you 1. Take XOR of this and this, and it will give you 1. And you can check this is same as that of this. So this is the way you generate or you convert binary to gray and gray to binary respectively. Now one more concept, one simple thing to note. We have seen that G0 is equal to B0, G1 is equal to B0 XOR B1, G2 is equal to B1 XOR B2, and G3 is equal to B3 XOR B2. Now what about you can say about gray to binary? If we convert from gray to binary, so we can see B0 is equal to G0 as usual. And what about B1? B1 is G0 XOR B1. Sorry, G0, this is, oh sorry, I am repeating it again. B1 will be, this B1 is the XOR of B0 and G1. And B0 is nothing. B0 is nothing from here. B0 is G0. So G0 XOR G1. So now B2. What you can say about B2? B2, this is your B2. B2 is B1 XOR this is your G2. Sorry. B1 XOR G2. And B1 is nothing but this is your B1. B1 is G0 XOR G1 XOR G2. And in the similar note, we can say that B3 is G0 XOR G1 XOR G2 XOR G3. So summarizing this, B2 is G0 XOR G1 XOR G2. B1 is G0 XOR G1 and B0 is G0. So this is the equation or this is the conversion equations for binary from gray. So this is the gray to binary conversion. Gray to binary conversion. So why